Hello everyone. I hope you all are doing well. Yesterday on day 1 of AutoWare, you learned how to automate Insta posts and WhatsApp messages. You ran all those Python scripts on your computer. But today, we are going to take automation to the level of application-specific embedded systems. So to get you all excited about automation, I would like to showcase one of the projects that I made in my freshman year. It will help you to get the gist of today's session. What are we going to learn and how will it benefit us? So here's the video. Introducing one of the smartest and most secure home automation system. Let's set up our device. Click on the add button and you will be presented with a QR code which we will scan using our home app. None of the Wi-Fi SSID and the credentials are being hard-coded. All of it is being transferred in an encrypted manner using the QR code. Now we are being presented with all the accessories that are connected to this device. We can also choose which room to place all these devices. We have temperature sensor and humidity sensor also connected to this device. And within a second, we will have all the devices in our home app. Not only this, we have the capability of controlling these devices from other mobile devices as well. Now, let me switch on another device. This device is connected through the main supply to 3 of my appliances. We have manual control as well. Let's see at a home app. Automatically they appear on the home app. This is using the mesh network which enables all the devices to be connected as nodes, and each and every node can be connected to the other neighboring nodes automatically. This not only solves the traditional problem of overloading in Wi-Fi LAN systems, but we have also increased the range of communication. This can easily be scaled up to a large agricultural field or an industrial factory. We have voice control as well. Hey Siri, what is the temperature in my home?
It's 28 degrees Celsius.
We can have cool automations as well. Hey Siri, I'm going to sleep.
Playing some soothing songs. Good night, Shaurya.
Sometimes it may happen that none of your devices are close to you and you want to control your appliances through voice commands. Let's try that. Marvin, switch on all the lights. We have also created a 3D mockup of our final prototype using Fusion 360. So, it's a home automation system like Alexa, Google Home, HomePod. But the difference is that the integration of various features is in a very tight package, which makes it one of the most secure systems that you can build as of now. You'll understand the meaning of the statement towards the end of the session. For now, I want you to spam fire emoji in the chat if you are geared up to it in this session. Quickly, I want fire emojis in the chat. Great. We'll start with the very basics. So what are embedded systems? Just I showed you a project. It was an example of embedded systems. Your air conditioner is an embedded system. It consists of a microcontroller, which is the brain of the system. It consists of various sensors to collect information about its surroundings such as temperature, humidity, etc. and some input or output I/O ports. For today's session, we'll be using the Esp32 microcontroller as the brain of our embedded system. Esp32, designed by Esp Systems, is a dual-core microcontroller unit with integrated Wi-Fi and Bluetooth connectivity. This opens up options for a wide variety of applications, which can interact with each other even when they're worlds apart. Well, that's an exaggeration, but you get the point. There are various other features of this MCU, which makes it one of the best options for carrying out automated tasks. We'll discuss them later in the session, but the important question is, how are we going to run our programs on this microcontroller? Before that, let's quickly get some info. I want this chat to be interactive, okay? So tell me how many of you are freshers here. Quickly in the chat, Write whatever year you are in, fresher, second year, third year, whatever it is. Quickly, quickly. Okay, so we have a mixed pool of freshers and second years. Mostly, I see many freshers here. Now, as I recollect from my past, you all must have learned Python. So let's go today with Python instead of commonly used, Arduino reference language or embedded C, C++, all that stuff. But the Python we normally use on our computers, also known as C Python, that you used yesterday to make your Instabots and all, it will not run on such a tiny microcontroller. And for that very purpose, MicroPython was introduced. So MicroPython is a lean and efficient implementation of the Python 3 programming language that includes a small subset of the Python standard library and is optimized to run on microcontrollers and in constrained environments. But, honestly speaking, Python is not the language for microcontrollers, especially due to poor memory management and relatively low speeds. Our ESP32 has 4 megabytes of flash memory. Okay, what is flash memory? It's that part of memory, or you can say that memory partition where all your code is stored. All the instructions that you will give your microcontroller to perform, they all lie in that very partition. And it is just 4 megabytes for our ESP32. If you compare it to your PCs, it's a very, very less amount. And that's the thing with Python. It's easy to learn and understand, but that comes at a cost of lot of abstraction layers which are dependent on each other. So even if you want to switch on a simple LED, you will be taking up a huge chunk of memory, whereas in C or C++ language, it's much faster and uses less space. But today's session is about giving you guys an idea of how to build applications and devices which make your life easier with the help of personalized automations. So I'll stick with MicroPython. Don't worry, we'll cover C, C++ and Arduino, all that stuff in later sessions as well. Talking about building things, I totally forgot that you guys may not have access to all these hardware components, but we always have simulation softwares, right? And don't worry, I'll also demonstrate how to work with the real thing. Okay, chat, tell me what all hardware simulation softwares have you used till now? I'm pretty sure that you must have done that particular subject, BEEE, Basics of Electrical and Electronics Engineering, in your first semester, and there you must have had J component. So you must have used some simulation softwares to carry out tasks and stuff. Okay, I see Proteus. Anyone else? Yeah, so see, you are familiar with simulations and other stuff, right? Yeah, I can see Tinkercad or CAD. The common ones are these only, Tinkercad, Proteus. But the problem is that they don't have option for simulating Wi-Fi modules. So before we proceed, there's one important thing, okay? I have two ways to continue with this session. First is that I tell you everything step by step like a tutorial. You follow along and we'll be done. You'll get some idea that you want to implement, but you didn't understand the reason behind all the steps, so you will have zero clue how to proceed. See, I'm not here to teach MicroPython or IoT or ESP32. You guys are attending this session because you are passionate about automation. So you should be able to navigate your own way around creating cool automation projects, and that too on your own, right? So my agenda is to teach you how to go about a certain problem statement and figure out the solution on your own. And in this whole process, we'll automatically learn how to create automations, how to learn IoT, all that stuff. It will automatically be done. Don't worry about that. So I would like to propose something that I'll act as a newbie, same as you. I know nothing. And together, we will figure out how to go about a certain problem. And when we are stuck, we'll take help from our best friend Google. So quickly create a poll and you have to select the way we are going to learn. Is it me acting like a newbie or a simple boring tutorial? I think you can see that poll as well. I'll wait for you, and in a time being, I'll end the poll. Okay, I'll give you 5 seconds. 5, 4, 3, 2, 1. Okay, great. I have 93% for newbie. I mean, that's pretty good. I'll go with the majority. So, first of all, let me end the poll. Great. Today's big problem statement is that we need to connect our microcontroller ESP32 to a cloud service. Send data to it, perform analytics, graphs and stuff, and based on that, create automations. Let's break this down to smaller problems. First, we need to learn how to program this microcontroller using MicroPython. And as we don't have access to the hardware, we need a simulation platform. So 3 keywords: ESP32, MicroPython, and simulation. So now I want you all to work alongside with me, open your Google Chrome and just do whatever comes to your mind. We have 3 keywords. Let's hop onto a browser window and search, ask Google for these 3 keywords. I hope you all can see my Chrome window. Now I'll just write ESP32, then the second one was MicroPython, simulation. Enter. See, the first link itself is create a new MicroPython on ESP32 simulation project. All the 3 keywords, we got it. Let's click on it and let's see what do we get. Okay, I mean, this is impressive. We have everything. This is the ESP32 development board. We have simulation written over here. We have a main.py, that means it's running Python or MicroPython specifically. Then, okay, one more thing. It's already written a simple print command on Python, print hello ESP32. We'll look into that later. Let's explore other stuff, what we can see here. We have diagram.json. Okay, the reason it's a JSON is the extension for JavaScript files. So the reason why it is a JavaScript file is so that this entire web page is responsive. We'll be simulating stuff. We'll be having different animations in this web page. So that's why JavaScript is used. So let's see version. Okay, 1 author anonymous maker. Okay, why? Okay, over here you need good observation skills for this session. Sign in, sign up is blinking and it's asking me to sign in. We'll do it in a minute. Let's check out the other things that we have in the JSON file. We have editor WokWi. Okay, WokWi is the editor. Okay, there is a link here. Let me open link in a new tab. We'll check that out later. Then we have parts. Says ID ESP type WokWi ESP32 devkit v1. Okay, what is devkit? Devkit is short for developer kit, and we are developers. We are going to develop some cool automations right now. So then we have connections. ESP to TX0. Okay, we don't need to worry about it. We'll figure it out later on your own. Simple intuition thing. Still, if you want, you can just Google TX0 and RX. What is monitor? Okay, so let's get into it. Monitor. To monitor something. Serial monitor. Serial. Where did you hear serial till now? I mean, serial communication. USB. Full form of USB, universal serial bus. Here I can see a USB port. So intuitively thinking, ESP, this is the ESP32, this is the actual microcontroller, or the SoC, system on a chip. So this SoC is the ESP32 microcontroller, and the entire black PCB that you are seeing is the development board. Why was there a need for this development board? See, these are the actual pins on the chip, okay, on the microcontroller. These are the gold pads that you can see. We cannot solder wires directly to these pads. These are very small, and also if you provide more heat to that, the copper layer will get corrupted and all that stuff. So it's not advisable to solder directly to those pins. So what they have done is, in this breakout board, they've broken down all these pads to pins. As you can see, D23, D22, TX0, all these pins are nothing but connections to these pads, which are pads for the microcontroller. Okay, we'll look into the other parts as well. Simple ESP-TX, like this, ESP-TX0 and ESP-RX0, TX0 and RX0. They are connected to serial monitor RX. Okay, TX is to RX, transmitter to receiver. Similarly, receiver to serial monitor transmitter. You have a dual way communication, receiver transmitter, transmitter receiver. That's it. Cool. Let's explore other tabs as well. We have a library manager. I'm sure that you guys are familiar about Python libraries, and everything in Python can be made into a module which can be packed into a library and distributed in open source, so that you need not write the same lines of code again and again. You can reuse that particular lines of code. This is the very basics of functional programming in Python. We have add a new library. You can upload your own library. Maybe you can download it from net and then upload it to this particular platform. And then we have save. It's disabled. I don't know why. We'll figure that out. Save a copy. We can download the project zip. Great. We can share it, but it's asking it to save it first. But save is disabled. Okay, maybe because we haven't signed in or sign up. We'll do it that. Wait a second. And docs. Okay. One more important thing. Always keep this in mind. Whenever you are learning a new thing, always refer to the official documentation. That is the best resource where you can learn that particular stuff, because it is written by those who have developed that particular platform. So we'll keep that in a new tab, documentation. Great. And now let's sign in. Okay, we have Google, GitHub, email. I'll use my Gmail. Wait a second. I hope you all are also doing it side by side. Wait a second, let me accept the two-factor authentication. Yep, I am signed in. Great. Now, okay, there's one more thing. Again, observation skills. In diagram.json, I can see a dot here. That dot represents that we may have some unsaved changes, and now the save button is also enabled. Just like VS Code, we have dot like structure when there are unsaved changes. Okay, great. Let's now see what did we get here. Okay, they have a Discord server. We can have fun over there as well. You can go on and join it. My projects, I think this is where our projects will get saved, and we can later on refer to them. The club, okay, nothing else is important for now. Let's start the simulation. We have main.py, which has written print hello esp32. Let's run it and see what all do we get. Okay, so hello esp32, it has printed that message. Then we have a bunch of other stuff as well. MicroPython version 1.18 on this particular date, that is 17 January. ESP32 module with ESP32 type help for more information. Okay, so MicroPython is running on this ESP32 version. This ESP32 module, this is the ESP32 module, this particular microcontroller. Specifically, if you want to know more about it, it is known as ESP32 Room module. Room spelled by WROOM, and then we have this entire ESP32 module. Sorry, development board. Great. Now, let's see this. It's saying here type help for more information. Okay, I'll do that. Help function. Okay, curly braces represent function, right? Simple stuff. We got a whole bunch of text. Let me increase the size of the window and we'll read about it. Welcome to MicroPython on the ESP32. Let me pause the simulation, why to waste resources. For generic online docs, please visit again. Yes, docs are very important and we'll keep them handy. Great. For access to the hardware, use the machine module. Okay, so as you know, Python is all about modules. So there's a machine module through which you can access the hardware. By hardware, they mean the pins and all the internal stuff of this microcontroller. So they have given us some examples also. Pin 12 equals machine.pin, this entire line. Just intuitively thinking, pin 12, this is a variable which is holding the value for this particular thing. And what is this thing? Machine module. Inside machine module there is a pin module. Okay, so there are sub modules in one particular module, and you'll get in just like subdirectories there are sub modules, and to navigate into those sub modules you need the dot operator in Python. Okay, so this is again a curly braces, so this must be a function which is taking 12 as the input. This must be the pin, like D22, D23, D12 should also be a pin, and then it is specifying machine.pin.out. That means machine.pin is same as this. Dot out is an extra thing. That means output. We are defining this particular pin as an output pin, and then we are writing that pin a value of 1. Pin 12 dot value 1. 1 boolean 1, logic 1, logic high, all digital system stuff. Logic high means the maximum voltage that your microcontroller can provide, it will be redirected to that particular pin. So in simple terms, that particular pin will be switched on, and if you write 0, I guess, then it will be switched off. Simple stuff. So let's move ahead. Pin 13 equals machine.pin13. Again the same stuff as before, but now we have a dot in. This meaning simple input pin, and another stuff is there, pull up. Okay, again simple English. Pull up means pulling something up, or pulling making it higher. By high we mean in digital systems logic high, again boolean 1, boolean true. So we are making the value of that particular pin, in this case pin 13, by default as logic 1. And as you know, our digital systems can only detect changes in the in their environment. So that change will be when by default it is true value, 1 value pulled up. We need to pull it down. We need to pull it down to ground. We have to make it 0 so that our microcontroller can detect a change and hence an input pin. And then we can print that value, print 13 dot value. If it we know that by default it is 1. And if it changes from 1, we know that we have some input. Great. Then we have I2C. Again, we are not going to look at it, but if you just search I2C, it is also known as IIC, I2C. It is inter-integrated circuit communication, a type of communication protocol. We are not going to get into this today. We'll look into it when we are taking the session of microcontrollers, specifically the Esp32. Again, then basic Wi-Fi configuration. We need to start with the basics, and the basic says simply switch on the LED of this microcontroller, turn on and off, or maybe blink an LED. That is the basic stuff. Later on we will get into the basic Wi-Fi configuration and see how to connect this ESP32 module, which has both Wi-Fi and Bluetooth. Today we'll be covering only Wi-Fi. We'll see it later. Okay, then we have control commands. Control A, you can read it. The most important one for now, I think, is Control C, interrupt a running program. Okay, so important thing. MicroPython, when we say MicroPython is running on ESP32, it is actually running and you can change the code. See, Python is an interpreter language. It interprets every line, it interprets a single line in a single clock cycle, you can say. That it goes line by line, and that's a very basic difference between Python and any other language which is used for programming microcontrollers, be it C or C++. What happens is you write your code on your PC, the compiler compiles it, transforms it into the binary code. That is, our digital systems can only understand binary systems, binary programming. So it is converted into a binary code, and then that is put into the microcontroller's flash memory. But here it is also in the binary format, but the entire MicroPython kernel, you can say, or an operating system kind of thing, is running on the ESP32, and it is taking up your flash memory, almost 2 megabytes of flash memory, and we only have 4 megabytes. So we need to take care of memory and all that stuff. That's why I said Python is not really a very good language to carry out this stuff, but it's simple. That's why we are starting with it. Okay, So let's see what else do we have. For further help on a specific object, type help object. Okay, for a list of available modules, type help modules. And that is all the help that we need for now. Okay, one more thing that I observed, let's stop the simulation and run it again. As you can see, this particular thing, it's an LED, it's a power LED, maybe because as soon as I switched on the simulation, it just started glowing. And if I switch it off, it is now off, and these two components seem similar to me. So this must be this also must be an LED, and this is on the board. So in a simple Google query that I want to search for ESP32 LED on the dev board meaning developer board that we are using, and directly we get the answer. ESP32, the LED on board is connected to pin number 2, but you not always trust directly, and it's not on the official documentation. It's some circuitdigest.com that is saying this. So to verify this, there's something known as pinout. So ESP32 pinout. What pinout does is it gives you the mapping of all the pins to the particular pin numbers and the entire peripherals that are connected to your microcontroller. So let's have a look. So the first image, it's the pads pinout. It's not the pin. It's everything is labeled for the pads, but we are using the development board, so we need to look for the development board image. Okay, so this is circuit for you. Okay, this seems fine. Let me open the image in a new tab. Okay, great. So we have a key over here, the key power. Okay, simple stuff, power or VCC, your positive voltage always indicated by red, standard, simple standards, and a ground, that is your logic 0, the ground power, negative power supply, that is ground, black, indicated by blank. Now we need to see whether the LED which the other side is saying that it's connected to 2 is a GPIO or not, because LED is an output thing, so it will be connected to a general purpose input output pin, GPIO. So GPIO is purple over here, as I can see. So we need to see if there's any GPIO2. So yes, there's a GPIO2. That means the pin number 2 of this ESP32 is a GPIO pin, and we can configure it as an output pin. So let's do it. We'll take help from the again the rep. This is okay. Can someone tell me in the chat what is this window called? You must have learned it. What is this window called? Where I can input commands. I'm seeing everything. What is this called? Quickly in the chat. Terminal, great. Yes, it's a Python's interactive terminal, and in MicroPython it's called REPL. So REPL stands for, you must have learned about this as well. REPL stands for read, evaluate, print, loop. So these are the commands that you can operate on this terminal. Now let's see. Let's write help again and see what all commands did we get. First of all, you need to run the simulation so that you can interact with it. Help. Okay, great. And I'll these are the output commands, so I'll copy these 3 commands here and paste it here. Okay, so importing machine pin 12. Now as I told that Python is an interpreter language and you can modify the code in runtime, which is not possible actually. But because of the MicroPython kernel, the operating system is designed in such a way that you can interact it in runtime, real time. So I'll step by step, I'll use these commands. Okay, first of all, the first command. Okay, so let's copy this and paste it in your REPL. These 3 arrows mean that you are ready for input. And if you're stuck in an infinite loop, just press Ctrl C so that you can get out of that and you can interrupt the kernel. So print hello ESP32. I should see hello ESP32. Yes, I see it. Then import machine. It should not give me any error. Import machine, no error. Now instead of pin 12, what I need is pin 2, right? And here also I'll change from 12 to 2, and same as here. Wait a second, sorry. Yep. Copy this, write it here, enter. No error, great. And now the final command, which is writing value to this particular pin. We are assuming that this is pin 2. Let's see what happens. Now I'll hit enter. Let's see what actually happens. Nothing happened. Pin 2 dot value 1. We wrote it and nothing happened. Why is it? Can someone tell me the reason? Okay, I'll give you a hint. What I'll do is I'll save this and restart my this thing. Okay, there's also a mistake, I think. Okay, can someone tell me what the mistake is? I have actually pointed it out, but still. Okay, doesn't matter. I just wrote 22 instead of 2. Okay, I'll perform the same steps again. Import machine. That's one of the disadvantages of this REPL. You can't edit your commands once they are executed. Great. Now pin 2 dot value. Now I think the LED should glow, and yes, it's a blue LED and it's glowing. Great. This was all cool stuff, but how to do this on real hardware? Now let's get into that. I'll stop the simulation here and we'll go to the official MicroPython docs that we got from the help. Okay, so here it is, I guess. Yes, MicroPython documentation, and immediately I can see quick reference for the ESP32. That is what we are using, so we'll go into that. See, installing MicroPython, getting started with MicroPython on the ESP32. See, the same thing, import machine, import ESP. All you can read this in the REPL UART0. We talked about RX is connected to TX or serial monitor and vice versa. We'll go into this, getting started with MicroPython on the ESP32. So what are the requirements? The first thing you need is the ESP32 chip. I have it. Okay. MicroPython software that supports the ESP32 chip itself. We don't have it right now because it was running on a simulation, but we don't have it on a PC. So for powering the board, you need a USB connector. Obviously, we saw that there was a USB connector here. Wait a second. This was a USB connector. So let me go back. We need to get the firmware, the MicroPython firmware. MicroPython downloads page. I can see the link, quickly open it. And here is 1.18.zip. Okay, tar, I can't uncompress the tar files, tar.exe, and I will use zip file. Okay, and why am I downloading 1.18? Because as you can see, MicroPython version 1.18 is running on our simulation as well. So to keep things simple and everything should be uniform with the simulation thing and the hardware, so that there's no difference, I'll use the same operating system. So I'll download this. Okay, great. Now we need to, one second, I think we have a doubt. Why was the ESP32 preferred over any of the RPi modules? Great stuff. So RPi doesn't have Wi-Fi built into it. The RPi, Raspberry Pi, the entire 3B model, that is not available for simulation, first of all. Second, the RPi Pico, the newest board of Raspberry Pi with their own custom silicon chip, that is available on this WokWi platform. If you want to see, I'll show it to you. See, one second, Arduino Mega, Arduino Uno, Raspberry Pi Pico project. But the thing is, this doesn't have Wi-Fi, so we won't be able to simulate Wi-Fi. That is the main motive of today's session. Okay, getting back to ESP32, we have downloaded this firmware for ESP32 MicroPython. Now what we need is, we need some IDE, because we need an interactive environment. I can't work in terminal, I just can't. So we'll just search for MicroPython IDE, see what we get. I hope Anirudh Pandey, I have cleared it out. Give me a thumbs up if it's cleared. Okay, till then I'll move on. Thorny ID is a great ID to program the ESP32. That is what we want, and it's available on all the operating systems. Okay, great. So let's download Thorny IDE. Thorny IDE, download. Great. Here you can download for your particular operating system, Windows, Mac or Linux. I have already downloaded it, and when you will open it, you'll see something like this. One second. I hope you can see the Thorny window. This is the window that you'll see when you install and run the Thorny IDE. And see, it's a very simple IDE. You may not have the same interface. I just went to Thorny and then preferences, theme and font. I changed to clean dark blue, just simple ID stuff. Now what we want to do is we want to run the interpreter. So you click on run, we click on select interpreter because Python is an interpreter language again and again, and MicroPython is the one that we need to use, and that too specifically for ESP32. As you can see in this list, there is MicroPython for Raspberry Pi Pico. Just now I told you ESP3266. Generic is it's general for everything. CircuitPython is another platform, or you can say programming language, a subset of Python used for these microcontrollers, but MicroPython is better. So we click on MicroPython ESP32, and now in the details you can see connecting via USB cable or connecting via WebRipple. WebRipple is an experimental feature. You can do it, but it's experimental and it's not very stable. So you can try it for your fun, but I'm not going to do that in this session. We'll go with the connection over USB. Connect your device to the computer and select corresponding port below. The corresponding port should have USB serial or UART. Okay, so two new terms. USB serial, it's in the full form of USB, Universal Serial Bus. UART stands for, you can just Google, Universal Asynchronous Receiver Transmitter. Again, this is another form of programming language. Communication protocol. So UART is also communication protocol. And let me switch to my camera, and I'll show you the actual hardware. Wait a second. I hope you all can see my camera. So this is the ESP32. I'll zoom in. Okay, so just like we saw in the simulation, there is this USB port, we have two buttons, we have that chip. This is a voltage regulator, a MOSFET kind of thing that you can see. This is a voltage regulator. Why we need a voltage regulator, if you ask? We saw in the ESP32 pin out that it was running on 3.3 volts, but your generic USBs, from your desktops and laptops, they output a voltage of 5 volts. So to convert that from 5 volt to 3.3 volt, we need a voltage regulator. Then we have some capacitors, diodes, all of that is protection stuff. General electric circuits, they need protection from, let's say you give more than 5 volts and all that stuff. That is required for those things. Then we have two LEDs. Let me just power it on, and you'll see the red LED switched on. The red LED is switched on. Similarly, we have a blue LED over here, just like in the simulation. And if I don't really want to get into the detail of this chip, but okay, let's just do it. This chip is the name is CP2102. What it is developed by Silicon Labs, and it's a USB to UART converter. That is the thing that we need over here, USB serial or UART. So what does it do is it's a USB is also communication protocol, UART is also communication protocol. The thing is that ESP32 cannot directly interface or understand USB communication protocol. So we have this chip, it takes all the USB data, converts it to UART, and then feeds it to the ESP32. Hence communication successful. You can program it, or maybe use a REPL. ESP32 is sending print command, or it's sending the output to the REPL, and you can see it on your console, on your PC. That is how the communication is going on. Similarly, you can program it. That is what we are going to do. Install or update firmware. So click on this. We need to select the port. Port again, see CP2102 USB to UART bridge controller. That is what we want to select. Then in the firmware, browse the firmware that you just downloaded. I'll go to my downloads. Wait a second, why am I not? Okay, because I didn't uncompress it. Wait a second, I'll uncompress the MicroPython 1.18, the firmware that we downloaded. Yep, I think it's now uncompressed. I'll again browse. I'll search for MicroPython. Okay, this is the binary file. I'll open it. Now from the flash mode, these are various speeds at which you can flash your ESP32. So flashing means putting your entire code and the MicroPython firmware into your flash memory. I told you the flash memory is the partition of memory where all your code lies, and MicroPython kernel is also utilizing that particular memory. So we have to be careful when we are creating multiple variables and all that stuff. And you need to click on erase flash before installing if it's not checked by default. This is to just to remove any possibilities of corruption of code. Previous code will be overwritten if you do this. Erase flash, all the previous flash memory will be erased and then it will reinstall. So to be just to be secure enough, you click this option, then we'll do install. Okay, the thing is, now it is starting and it's now written serial port dev cu.usb serial 001. That is the exact path of the device which has been configured. In your Windows, you will have simply COM ports, communication port, short for COM port, and in Mac or Linux, you'll have devices file, dev files. Then inside that directory you have cu.usb. That is the exact path of your USB device. So let's see it has thrown an error, and a fatal error occurred, failed to connect to Espressif device. Espressif ESP32 is developed by Espressif, so it failed to connect. Why? Because it was not in the bootloader mode. So again, there's one more concept of bootloader mode. Bootloader mode is simple. What is bootloader? The entire memory is the flash memory, but the CPU, your cores. I told you that our microcontroller ESP32 is a dual core microcontroller. That means it has 2 CPU cores. None of the CPU knows what instructions to perform on startup. So the bootloader tells the CPU, first of all, the CPU asks the bootloader, again a memory partition. Bootloader is nothing but a memory partition where the initial setup is stored. So CPU asks the bootloader, what do I have to do? Bootloader tells that you need to go to this particular memory address of the flash memory and start executing every code that is present over there. So bootloader is not present over there and we are not in the bootloader mode, because if by default always we are in the bootloader mode, when we are powering the ESP32, we have a doubt that it can be get corrupted, because you have opened your bootloader. Always you are in the bootloader mode, and whenever the CPU asks for instructions, bootloader, if that gets corrupted, you will never be able to execute the commands and you will never able to reach the MicroPython kernel, because that itself is stored in flash memory. So that's why by default the bootloader mode is disabled. For that, our development board has provided us with this boot button. I think you can see BOOT, this is the boot button and this is the enable button. EN, it must be written over there in your module as well if you have it. EN stands for enabling or disabling the chip. Okay, so when you click it, you enable it, and when you release it, you disable it. So I told the opposite. When you click it, it goes to 0 and hence you disable the IC, and when you release it, it again goes back to 1, just like the pull-up feature that I told you in the beginning, and the chip gets enabled. So you're disabling and enabling it. This entire process is known as resetting of the ESP32 microcontroller, of any microcontroller. So what we need to do is, we need to hold down this boot button while we are installing a firmware. So let me do that. I'll again click on install and I'll press this boot button. And now it's erasing flash memory, because it has all the instructions, all the address of the flash memory and everything is done. It's now writing at those particular memory addresses because the bootloader was enabled. So once it is writing, you can leave the boot button, because now it's entered into the flash memory. It has all the instructions and it can write it. Let it be, and let's wait for it to complete the entire instructions. 22% is uploaded. Great. Till then, do you guys have any doubt? Regarding anything? Okay, it's now 70%. No doubts? Great. I think there's a delay in the live chat, but no worries. %98 and it's about over. Yes, it's over now. And see, it wrote let me tell you, it's just more than 1 to 2 megabytes. Okay, so it compressed it. It wrote in 87.5 seconds. And verification, again, we'll look into that. I told you that ESP32 is very secure microcontroller. That is why it verifies everything. Even when you reset the chip, millions of operations are happening in 1 second to verify whether the code which is running on the ESP32 from the flash memory is uploaded through my computer or not. That is all. That is how secure this particular microcontroller is. So done. Okay, let's get into it. Close, cancel. Now it's written here, backend terminator or disconnector, use stop or restart to restart. Okay, let's do that. Here's the stop restart backend. I'll restart it and let's see what all do we get. Again, the same exact thing that we got in our simulation. MicroPython ESP32 module with ESP32. Type help for more information. We can type help and exact same thing. So let's just try to copy whatever we wrote in our simulation. 1 second. We'll copy this. We'll go to our IDE and here's the run current script. Okay, so it's asking us to save, and where to save, this computer or the MicroPython device. Everything you do, and main.py file is the file that you will run as soon as your MicroPython gets the flash contents. So you need to save it on your MicroPython device with the name of main.py, and as you can see, there is already a file present, boot.py. Boot.py, again short for bootloader. These are the instructions that will be performed when the MicroPython gets loaded up, and all the basic setup can be written in boot.py. We are not going to look at it, but to make your Python file, main Python file, bit concise and short, you transfer some amount of code, the basic setup, to boot.py. Okay, so click on OK, and we have hello ESP32. And let me switch to my camera. We'll see that our LED is also glowing. 1 second. See, the blue LED, it's also glowing. Now let's just blink it. That's the only thing remaining. To blink it, what does an actual blink mean? It means that the LED is on for a certain amount of time and is off for a certain amount of time. So we need to control the time, and for that we need the time module. So let me go back to the Chrome window and we'll see, do we have time module in MicroPython? Yes, we have time. And always go to the official documentation. This is the official documentation page, docs.micropython.org. Okay, so let's get into the functions. We need to give input as seconds, and I can see time.sleep, sleep for a given number of seconds. So what does it do is, it's a blocking code. Generally it's not advised to use time.sleep and time.sleep millisecond, ms for millisecond, and then we have us or mus standing for microseconds. You can give command input in that particular unit. We'll be using time.sleep, and also it's not advisable to use time.sleep because it is actually blocking your entire microcontroller. You can't do anything else while you are executing this time.sleep command. So let's say you say time.sleep for 1 second. For 1 second, even if anything happens to the microcontroller, it will never get to know that, and that's not very advisable to do in a real-time system. But today we are just blinking LED, simple stuff, so we'll use it. Also, it's written as sleep for a given number of seconds. Some boards may accept seconds as a floating point number. So floating point number or float values are decimal values, 0.2, 0.3, all that stuff. We can say 0.5 for half a second or 500 milliseconds. But how is this possible? Only some boards accept this. Why? Because they have a floating point unit or FPU. Floating point unit is the thing inside the microcontroller that enables it to interpret 0.2, 0.3, 0.5, all these float values. Most of the microcontrollers nowadays have this floating point units. Earlier, they never had it, and it was a very privileged kind of thing to have a floating point unit. Okay, so let's get back to our the hardware demo. Okay, and we'll import the time module. Import time, and then we'll see what the code was. Time.sleep. I'll just copy it. Can I copy it? Yes, I can copy it. And I'll go back. Okay, we need to switch it on. Okay, we need this to happen continuously. So what I'm going to do is I'm going to enter into an infinite loop. In Python, we enter into an infinite loop using while loop. So while true, obviously it will always happen, or true is always true. So while true, enter. I'll cut this command from here and paste it here inside the while loop. Always take care of indentation in Python, so that's an important thing. Pin2.value, then we need time.sleep for, let's say, 0.5 seconds, and then again the same thing, but the opposite, that we need to switch it off, taking care of indentation. Always hit enter, and I'll change this 1 to 0. So I'll run it, and let me first switch to the camera. I think you can see my camera, and I'll run it, and our LED is blinking. You can perform the same thing in your simulation as well. Just copy this code, and we'll go to the simulation window, paste it here, save it, start your simulation, and we should see that our LED on the simulation is also glowing. So we are common across all the platforms. So it's just like you are doing on the actual hardware, and I'm also showing it. You are completely covered. So now let's now if you are done with this, let's go for a coffee break. Okay, a 2-minute coffee break, and after that break we'll see how to connect this ESP32 to Wi-Fi, then to the internet, and then send data to the cloud. We'll be using IoT Cloud services, all that stuff after the break of 2 minutes. I'll maybe put some song. Okay, it was a good break. Now let's talk about IoT. The Internet of Things or IoT is influencing our lifestyle from the way we react to the way we behave. From air conditioners that you can control with your smartphone to smart cars providing the shortest route or your smartwatch which is tracking your daily activities. IoT is a giant network with connected devices. These devices gather and share data about how they are used and the environment in which they are operated. It's all done using sensors. Sensors are embedded in every physical device. It can be a mobile phone, electrical appliances, barcode sensors, traffic lights, and almost everything that you can come across in day to day life. These sensors continuously emit data about the working state of the devices. But the important question is, how do they share this huge amount of data? And how do we put this data to our benefit? IoT provides a common platform for all these devices to dump their data and a common language for all the devices to communicate with each other. Data is emitted from various sensors and sent to the platform, IoT platform securely. IoT platform integrates the collected data from various sources. Further analytics is performed on the data and valuable information is extracted as per requirement. Finally, the result is shared with other devices for better user experience, automation, and improving efficiency. Let us look at a scenario where IoT is doing vendors. In an AC manufacturing industry, both the manufacturing machine and the belt have sensors attached. They continuously send data regarding the machine health and the production specifics to the manufacturer to identify issues beforehand. A barcode is attached to each product before leaving the belt. It contains the product code, manufacturer details, special instructions, etc. The manufacturer uses this data to identify where the product was distributed and track the retailer's inventory. Hence, the manufacturer can make the product running out of stock available. Next, these products are packed and parceled to different retailers. Each retailer has a barcode reader to track the products coming from different manufacturers, manage inventory, check special instructions, and many more. The compressor of air conditioner has an embedded sensor that emits data regarding its health and temperature, as you can see in your screen. This data is sent continuously, allowing the customer care to contact you for the repair in time. This is just one of the million scenarios. We have smart appliances, we have smart cars, smart homes, and smart cities where IoT is reducing and redefining our lifestyle and transforming the way we interact with technologies. The future of IoT industry is huge. This is how data flows in an IoT ecosystem, from devices to the cloud, and then after processing it reaches to the end user. And this happens in opposite direction as well. This is model of Google Cloud IoT Core, and we have other cloud platforms such as Amazon Web Services, AWS, Microsoft Azure, etc. Today we are going to use ThingSpeak. So why did I choose ThingSpeak? ThingSpeak is developed by MathWorks, and MathWorks is the same company which has developed MATLAB, and I'm pretty sure that all of you are familiar with MATLAB. Okay, so let's just get into the ThingSpeak IoT Cloud. Other cloud platforms are Blind, Adafruit, but ThingSpeak again, you are familiar with MATLAB, that's why I chose this. So ThingSpeak is an IoT analytics platform service that allows you to aggregate, visualize, and analyze live data streams in the cloud. It provides instant visualizations of data posted by your devices to ThingSpeak, and you even have the ability to execute MATLAB code in ThingSpeak so that you can perform online analysis and processing of the data as it comes in. ThingSpeak is often used for prototyping and proof of concept IoT systems that require analytics, just like what we are doing right now. So let's now jump to our Chrome window and set up ThingSpeak Cloud. Just search ThingSpeak. ThingSpeak.com. And here I want you to go to channels. See, these are all public channels, and you also can make your public channels contribute to the open source community. We have from San Diego, we have air sensor readings from different locations. You can use these data to perform further analytics and do automations, all that stuff. So let's sign in. first with your MathWorks account. I guess you all must have MathWorks account because MathWorks is affiliated with almost every university in India. So let's just do that. Something like vitstudent.ac.in for VIT students. Then, okay, password. Great. Now, as you can see, we have in this channels, we have my channels, watched channels, public channels. Then we have apps. We have all the MATLAB apps and ThingSpeak. ThinkTweet is another thing that you can, your devices can send data to ThingSpeak, and then using ThinkTweet, you can tweet about that data and maybe, first perform some analytics, and then all the result of that analysis can be posted to Twitter. Then we have apps is done. We have devices, MQTT. We are going to look into that. Support, documentation. Again, keep the documentation handy. Now I want you to go to channels and then public channels. 1 second. Public channels. Okay, sorry, my channels. Yes. So these are going to be your channels that you will create using new channel. Let me give it a name. Simple RAS AutoWare. Description, it's optional, but no need for now. What I'm going to do is, from our ESP32 device, we'll have a simple counter variable, and that we'll increment it in each iteration of our infinite loop, and then we'll send that particular counter variable value to ThingSpeak. So let's just write it as counter, and there you can create multiple fields, up to 8 fields. Then metadata, it's all optional stuff. Go down and just save the channel. When you save the channel, you'll see channel ID. Then you have the author. This must be some random code that is assigned to me by the MathWorks account, and the access is private. We are only I can see my channel. You can also set up your public view, but we are going to just look at private view because then it becomes much more simpler. You can add visualizations. They are nothing because we have no data. By default, you get a field chart, line chart, and you can add widgets, export all the data to a CSV or an Excel file, and then perform analysis. All your charts, bar graphs, all that stuff. We'll see that later. And there are entries. There are no entries, 0 entries created less than a minute ago. You have the channel status. That is it here. Let's go to the channel settings tab. These are the settings that you can change whatever you missed in the previous page as well. And then we'll go to API keys. So API keys, can anyone tell me what's the full form of API? Quickly in the chat. Guys, what's the full form of API? Does anyone know it? Yes, exactly. Application Programming Interface. So, application here is ThingSpeak. The programming interface will be set up by MicroPython so that our ESP32 device can communicate with this ThingSpeak server. It's okay. What all is happening here? ThingSpeak is nothing. It's a remote server. It is also a computer located at some remote location, and we are accessing it via the internet. Okay, so first of there are two keys that we can see here: write API key, read API keys. So from this channel, and then we have the particular field, the counter field that we created. We can either write to it or we can read data from that. So to make things secure, they have provided us with keys. Only those who have this API key can actually write and read data from that particular channel and from that particular feed. Okay, so here are the API requests. So as we are saying, communicate. Can anyone tell me any of the communication protocols that your web interface use? I know that you must know at least one of the communication protocols used in web interfaces. Quickly in the chat, can anyone of you tell me the communication protocols that you already know, which are used for web interface? HTTP, exactly, Hypertext Transfer Protocol, and there's a hint in on the screen itself. Get, post. Get is a get request, HTTP request. So with that, let me come to the initial slide. Wait a second, I'll switch to my PPT, and here you can see that don't get overwhelmed with the all this text. I've just written it for your information. You can read it after the session ends properly. You can all of this is recorded. It will be available in the same link, so you can go back and read it later. For now, I'll just tell you there are two major protocols, HTTP and MQTT. So HTTP is Hypertext Transfer Protocol and MQTT is Message Query Transport Telemetry or Telemetry Transport, same thing. So your HTTP is a communication protocol which is used by the REST API, or you can say RESTful API, and it's nothing, it's an architecture which is a representational state transfer architecture, and it's a request and response kind of model. So you request data from it, you'll get a response, and anyone can do that. So that is how HTTP, when you are requesting a particular web page, you request a server for that web page, it gets a response, it will give you I think when you are using a get request, you're getting HTTP OK back 202 OK, all that stuff, simple HTTP and HTML, sorry, simple HTML. And but the major thing here is MQTT. This MQTT protocol was specifically developed for IoT devices, and the reason being MQTT, HTTP, see, you are continuously requesting the data from the server and then you are waiting for the response. So it is a bit slower, and especially when you are writing data, the MQTT publish operation is typically faster. Okay, so MQTT is a publish and subscribe model. So by this, to give you an example, consider the YouTube channel. So you subscribe to a YouTube channel. As soon as the channel owner updates anything to its channel, you get a notification. So if you want, you can switch on the notification for IEEE RAS channel on which you are watching this video, this session. So as soon as we update anything, you'll get the notification, and that is exactly what we want. Our devices need not worry about continuously polling data from the server and checking whether new data has arrived or not. This will consume more power, and we know that our microcontrollers are low power devices. We have a constraint of battery, so we need to preserve our battery. So for that, MQTT is extremely good, and how it helps us is that each time the data is updated in a channel, you automatically get the notification and updates to your device. And why is it happening? Because MQTT communicates over WebSockets. So as you can see in the slide also, in the third line, MQTT over WebSockets. These WebSockets, like just the term itself, socket, you are plugging into the device, you have a complete integration of the device as well as the cloud server, and that is why you have such low power consumption and immediate response whenever the data is updated or anything else is happening. And this is how MQTT helps us. So now let's go back to our Chrome window, and now we need to see how we can communicate ESP32 to the ThingSpeak. So for that, we first need to learn how to connect ESP32, our microcontroller, to Wi-Fi. So let's do that. ESP32, then we are using MicroPython, and then Wi-Fi. Again, docs, network basics, let's get into it. So as you can see just from the initial example that they have given, import network. Network is a module which is handling all the Wi-Fi connections. Then we have STIF and APIF. Again, a very important concept. Station and access point. So compare your ESP32, the Wi-Fi which has inbuilt Wi-Fi, to your mobile phones. Your mobile phones also have modems or the Wi-Fi adapter that you place into your computers, and the Wi-Fi modems that is built into the SoC of your mobile phones, be it Qualcomm or Intel. Okay, so your mobile phone can connect to Wi-Fi, or you can say that it can connect to the internet via your router. So with your router, it has an additional access point, and to that access point you connect your Wi-Fi station. So when your mobile phone is connecting to your Wi-Fi router, your mobile phone is acting as a Wi-Fi station, and it is accessing internet via the access point. As the name suggests, access point, it gives access to the internet, to the data which is held by the server. Similarly, your mobile phone can also operate in hotspot mode. What happens there? Your mobile phone is acting as the access point, and all the devices that are connected to that hotspot, those are acting as the Wi-Fi stations. Similarly, our ESP32 can act as Wi-Fi station and Wi-Fi access point. And one more thing that your mobile hotspots can do is, mobile phones can do is, when in hotspot mode, they not only give access to the data on the mobile phone, but also to the external internet, the internet, the Wi-Fi. So that is how it is being done, because it's acting in dual mode. So dual mode says that you can act as a station as well as access point simultaneously. So your mobile phone is acting as an access point for rest of the devices which are going to connect to that hotspot, whereas it is also acting as a station mode to get connected to your router, so that it can have access, so that it can gain access to the external internet, the World Wide Web. So our ESP32 is just like that, and today we are just going to connect our ESP32 to a Wi-Fi. So our ESP32 will be acting as a station, and a Wi-Fi has a router. Wi-Fi router has an access point. We are going to connect to that. So we will be using the STM mode or the station mode. That's the concept here. Now you can check if the interfaces are active by this command. So by default they are not active, and we need to make them, activate them, so that we can run our Wi-Fi. Then the network settings can be obtained by .ifconfig, and I am pretty sure that this is common for all STIF, or we can even write sta_if.config. Okay, so let's try this. We'll go to our WokWi simulation platform, and I'll copy this, or we need not copy, we just go there. I'll delete all this, and I have imported the network. Okay, now the network module is imported. What we need to set up our wireless LAN, so that we can communicate to our router. So let's go into that and see how to set up Wi-Fi and ESP32. One second. Quick reference for the ESP32. Again, I'm going to the docs. First we visited to this particular documentation. Now I'm specifically going to the ESP32 documentation. Great. Let's see, networking. Yes. So import network. Then we have all the example. What we can do, we can see, we can activate the interface. We can scan for access points. That is scanning for your home Wi-Fi. We can see whether it is connected or not. Then we can connect with a particular SSID and password. We can configure the MAC address, all that stuff. ifconfig is the IP netmask, gateway, and DNS address. So all these details you may see when you log into your router using the admin. So let's do that. AP is the APIF. We don't need that. We need the station mode. So let me just copy this, or we can simply write. Yes, it's simple stuff. Okay, so now what we need to connect it. Okay, so for that, let's create a simple function kind of thing that we'll be printing connecting to Wi-Fi. Great. Then what we need a Wi-Fi, or we can store the network.wlan that we saw in the documentation in a variable. Again, it's not advised to do that. Again, I told you, unnecessarily wasting your memory, but it's easier to code in that way. Later on you can replace wherever you are using this variable with the exact path of that module. So we'll use let's say Wi-Fi equal to network. We'll access the network module, then we'll go for the WLAN module. WLAN is nothing but wireless LAN, and in which mode? The station mode. So network dot sta underscore if, if I'm not wrong, network. Great. Oh no, sorry, no semicolon, it's not C. Then we need to activate it, so we'll say Wi-Fi dot activate. See, again, network dot WLAN, this entire thing, and then saying dot activate. Instead of that, we are just saying Wi-Fi dot activate, and activate it to true value so that it's activated. Now we need to connect it. So first of all, connect it to what? We need to scan for what all networks are available, to this particular simulation platform. Let's try Wi-Fi dot, I saw scan function. Wi-Fi dot scan for access points. So let's go here, Wi-Fi dot scan, and save it. Okay, we have to return whatever scanning we get. Let's print this, print Wi-Fi dot scan function, whatever the value is returned. Save it, start the simulation. Okay, we got an error, track connecting to Wi-Fi. WLAN object has no activate. 1 second. Okay, it's just active. Save it, restart the simulation. Connecting to Wi-Fi. Okay, let it connect. WokWi guest. Okay, so WokWi guest is the, again because the name is WokWi, is the SSID of the network which is available to us. Okay, so now let me take some seconds to quickly tell you about this WokWi platform. So as you know, there were not many platforms which allowed us to simulate Wi-Fi modules. So guys at WokWi, they decided that they will build such open source platform, and they have provided us with a server which is known as WokWi guest, and we can connect this ESP32 in simulation to that server, and that server will act as a gateway to the rest of the internet. So, and let's go to the WokWi documentation and I'll show you. Here's the WokWi documentation, docs, guides. Let's go to ESP32 simulator, and here you can read it in detail. It's very simple. We have examples as well for MicroPython and for Arduino also. We'll check out Arduino later, in later sessions. So let's go for Wi-Fi simulation here. WokWi guest is an open Wi-Fi network, no password required, and WokWi Club is also there. It's a paid subscription, so you have more bandwidth, and we may come across some issues on this open network. So let's see. We have WokWi guest. Now instead of scanning, what I'll do is I'll connect to this WokWi guest. Wi-Fi dot connect, and let's see what are the argument for this function. In connect, we need two strings, the SSID and the password. ESSID is nothing but the SSID, that is the name of the Wi-Fi WokWi guest. Okay, I'll copy this and I'll put it in strings. WokWi guest, comma, they told us that there's no password, so I'll enter an empty string. Great. Now to see whether it is connected or not, we'll print out whatever the information network configuration that we are getting. That is this ifconfig function. Let me just copy this, and I'm going to do that print. Sorry, we need to specify of if configuration of what? Of Wi-Fi. Wi-Fi dot ifconfig. Great. And let's save it. and restart the simulation. Okay, so we got the all the IP addresses 000. It's connected to Wi-Fi. That's why only it printed this, because it would have given us error over here only. So we have the configuration. It's 000. Doesn't matter. It's a simulation only. Okay. So now what we need to do, if we have connected to this WokWi guest, now we need to interface the ThingSpeak Cloud. How to connect to that ThingSpeak Cloud? We just discussed that we'll be using MQTT protocol. Let me just pause the simulation, and now we'll see the ThingSpeak official documentation. Wait a second. This is the ThingSpeak API reference. See the HTTP API and the MQTT API. So we'll go to API reference. Inside API reference, we have REST API, which is the HTTP, and we have the MQTT. We'll go to MQTT API, and let me just close this downloads bar. We'll go to MQTT API, and now what we want to do is we want to publish data to our channel feed. So here we have the link. We'll go to that. So what all do we need in MQTT? We have a topic, we have the fields, publish. Okay, so let's just see this channel, then the channel ID that we have created, then we want to publish data, or we can subscribe to it. That is the task for you guys. We'll first look into publish. Then we have publish to what? Publish to this particular field, publish to fields, and then the field value. In our case, the counter was field 1. Let me show you. In the channel settings, I guess, yes, field 1. Okay, so we need to publish data to this particular field. Let's go back and see what other things we have here. Okay, first of all, we need to see how to write code for ESP32 to connect to ThingSpeak using MQTT. So we'll write ESP32, or even just we can write MicroPython MQTT. Again, refer to the official documentation, nothing else. So I'll find the official documentation, read the docs, umqtt.simple. So U or mu standing for microcontrollers, MQTT for microcontrollers. So it's a lightweight subscription model, that's why we are using it. And here we can see all the methods. We have a set callback. It is used when we are receiving data. We are not receiving data as of now, we are sending data. It's a subscription callback. As I told, that whenever the data will change, automatically will get an interrupt, and this callback function will automatically get executed. So this is something that you need to figure out your own. I'll be giving a task after this session. Now we are going to see the publish method. So here we have a mqtt.publish. First of all, we need to connect to that MQTT client, and the parameters are the clean session equal to true, and we need to specify what topic are we connecting to it. And again, the second thing is what is the URL, what is the exact path of that ThingSpeak server. Again, ThingSpeak server is nothing but a computer, but at a remote location. Great. So we can have disconnect, we have ping, we have publish, wait message, check message. Let's look into that, what all is there. Wait message and check message, main loop iteration, you can read through it. The basic things that we need, we have figured that out. mqtt.connect. Okay, so first of all, connect to what? We need the URL. Let's go to our MathWorks documentation and see what is the URL for this MQTT publish. So publish to, let me go to MQTT API once again and publish to a channel feed. And here we can see all the examples. See, I told you about Twitter and tweeting about your data. We have the example. Okay, so here we have the name, the channel name, client ID, host. This is the URL, MQTT or mqtt3.thingspeak.com. And then we have topic. This is the topic, channels, channel ID, publish, then publish to what? Field 1 or field 2, and then all the message that you want to send. So let's do this in our MicroPython. So let me first create a variable for the URL. So server URL, server underscore URL equals to, what was it in strings, mqtt. Let me just copy it or else I'll make mistakes. MQTT3 is a secure one. I don't think it will be supported here, so I'll simply use MQTT1. 1 second. Come, just paste it and delete this 3. It's the latest server that they have created, and it's not very stable, so we'll stick with MQTT only. So we have created a server, we have created a variable with the server URL. Then we need to create a MQTT client. For that we need to import that particular library that we were looking at, the umqtt.simple. Okay, so let's import that. Import umqtt.simple. And also I don't really want to import the entire library. I just want the MQTT client. So what I'll be doing is, from this entire library, I mean it's basic Python syntax, import MQTT client. What was it? 1 second. MQTT client, copy this. Great. And let's create a client. So client equals to, we need to call this constructor MQTT. This we need client ID, server port, password, keep alive. SSL is nothing but secured socket layer. You can Google about it. It is regarding the security parameters about this entire communication protocol. You can secure it, but today we are not going to do that. Keep alive, whether you want to keep alive the connection with the cloud, I advise you not to do this, because then you will be increasing the traffic and then you will get server issues. Password, if your user password, we just saw that in the ThingSpeak example, we'll feed in all that information. So let me go back here. I'll say that client is my MQTT client. Okay, it has autofill as well. Great. Let's give it a simple name, a string value. What is MQTT underscore client, and then we'll provide the URL that the client, what is the MQTT client will connect to a server, and that server URL we have to provide it. So that is server underscore URL. Great. Now let's go back to the MathWorks thing and topic. This is the topic. Let's just copy this. What will be the entire topic? The topic will consist of this particular thing that we just copied. Again, this will all be topic. Okay, 1 second. Topic. And all of this has to be in what do you say, string. Great. So instead of this, I'll use my channel ID. I'll go to channel settings, and here I can find my channel ID. Copy this, go back to the simulation, paste it here. So at this particular URL, server URL, we need to specifically go to the channels directory. Then in the channel directory, our channel that we created just now, then we need to publish data to it, but published, we need the write API key. So another thing that I need to add is write API key. And where will I get it? In my ThingSpeak settings, API keys, write API key, because it is needed so that we can write to that channel, to that particular field. So we'll go to write API key, we'll paste it again. This has to be in, it has to be a string, so put it in quotes. Great. So we have specified the topic. It will be this entire thing, channels, then the channel ID, publish, plus wait a sec, plus the write API key. Yes. Great. Now that we have done this, let's connect our client to the server. We have initiated all the settings, just like we initiated Wi-Fi equals network.wlan. We initiated Wi-Fi, but we need to use the MQTT connect command to connect this client to the server. So let's go into that and see where is the connect command, the function, connect function, MQTT client.connect. Let's go back and do that. Again, you should not always be connected to the server because you are increasing traffic. So I'll do this in a while loop, and I'll continuously connect. I'll then send my data, and then I'll disconnect when my all my data is sent. So I'll do this in a while loop continuously. And what we can do here is while true, infinite loop, and let me make a counter variable. That is what we are going to send. Cnt, let us counter cnt equal to 0. Again, no semicolons. Okay, keeping care of indentation. So now what we want to do is we need to specify what will be our message that we want to send. So it will always get updated with the new counter variable. So let's just do that. So payload or a message, you can write anything. Payload is equal to, we need to specify, see, till now we have just given this topic, but we haven't specified to which particular field, that is field 1. So we need to specify field 1. We need to write to field 1 equal to, and then I'll convert the counter variable to a string. So str cnt count, and I'm done. This is my entire message. I have to send it. So to send it, first connect the client. So client dot connect function. Then we need to publish this data. So as we saw in the documentation, there was a publish function which requires a topic, then requires a message, and again retain equal to false. Always, only case when you want to do retain equal to true is when you want to send data to multiple fields. So you send data to first field, then you retain the connection, send data to second field, retain the connection, and in the last field you keep the retain equal to false, which is by default false. This is a default parameter. Okay, so topic and message, that's the only two things that we require as of now. So client dot publish to a particular topic, and with the developed payload that we just initialized in our variable. Great, this is done. We have published data, and let's, after, if it has successfully published, let's just print whatever it has, the counter variable. Let's just print that, and after that what we can do is what we need to do is we need to disconnect. We don't want to increase traffic. So client dot disconnect, and maybe we can add some delay because it's a low power device, so you can't do it continuously again and again in seconds. You at least need 10 to 15 seconds of break. So we are not going to have it here, but let's just import time. Okay, also from time I just need sleep, so why should I include the entire library? So I'll just write from time import sleep, and I'll say sleep for, let's say, 1 second, and just for simulation purpose. I think we will face some problem, but we'll rectify it, don't worry. Okay, save it, and let's see if this will run or will it give. Okay, what did I just do? 1 second. Oh my goodness, didn't I save that? Oh, the entire code is gone. Wow. Oh, it was an incognito file as well. Great. 1 second, let me go to my projects. Less than a minute ago. Yes, thank God you saved it. Okay, so let's start the simulation. Connecting to Wi-Fi, but we got an error. What error did we get? Traceback in main.py line 20, client.connect, and what it has written? Lines in connection error, Esp32 module. Okay, we are getting some error in umqtt simple.py. In the library that we have imported, we are getting error in that. So let's see why are we getting some error. First of all, we haven't done something. We haven't even updated a counter variable, so that's one more error, a logical error you can say. So let's just traverse the entire code from the beginning. We have imported, wait a second, what is happening? Yes, so we have, let me save it first we have imported our network module. Then from that we have imported our MQTT simple, then MQTT client, and then from time we have imported sleep. Great, connecting to Wi-Fi, it is getting connected to Wi-Fi. Okay, let me check this whether it is actually connecting to Wi-Fi or not. To check that, what we can do is we can create a while not loop. Just like while true loop, we can connect a while not, and to check that we have that function, right, Wi-Fi dot is connected, which will return the status of Wi-Fi connection. So we'll do that. Wait a second, we can write here wlan w activate true connect. Before that, let's say while not Wi-Fi dot is connected, is my spelling right? Wi-Fi dot is connected, yes, it's correct. Let's enter this, and what I want to do is I want to wait. So let me just do this. I'll connect it, then I'll start printing dot 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 dot, so that we have some kind of indication whether it is connecting or not. And when it is connected, it will come out of this loop and it will stop printing dot 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 dot. So let's keep a delay in the dots of 0.5, let's say, and then we can print, we can print dots, and we need to end with a string, else it will go in a new line. Great. And if that is done, I want to print my Wi-Fi config. Yes, that is correct. Let's see it. Save, restart the simulation. Connecting to Wi-Fi dot 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 dot. Yes, now we are getting some. Okay, yes, the counter is also updating. 1 2. Let's quickly check our ThingSpeak channel private view and see whether we are getting any entries. No, we are not getting any entries. Let's just reload it, and we didn't get any entry. Why? So let's go back and see whether we have specified everything correctly or not. Again, we have connected to Wi-Fi. Now it's the part with the MQTT. So we are specifying the server URL, that is mqtt.thingspeak.com. Then we have a client ID MQTT client. So let me just pause this, because we are it may be an error of the simulation as well, because the server has limited bandwidth. So MQTT client server URL. Great. We have write API key. This is the write API key that our ThingSpeak has given us. Then we have the topic is channels / the channel ID, then /publish. Oh great, again an error, simple error. We didn't specify the // publish, then the further command for the directory of write API key. Let's just save it and restart the simulation. Connecting to Wi-Fi dot dot dot. We have got our network configuration, and we should see at one entry in our ThingSpeak. Let's just refresh this, and we have a one counter 1. Great. Let's do the same thing in our actual hardware as well. I'll copy all this data, Command A, whatever browser is, Control A, Control C. I'll stop this. I'll go to my demo video. Let me zoom in. Let me connect. Our pre-existing code of Blink is already running. So just paste that entire code that we just copied. And we can't run it. See, the run button is disabled. Why? Because it is stuck in an infinite loop of Blink. So to do that, first of all, it's also saying use stop or restart to reconnect. So let me do that. And now we don't have these three arrows. So to get that, the command was Control C, right? So I'll just press Control C and let's see. Yes, now we have the input command and now the run is also enabled. Let's run it. Connecting to Wi-Fi. Okay, but the Wi-Fi is not the same as that one. Wait a second. Let me interrupt it again. Control C, and I want to run Wi-Fi.scan first. Oh, sorry, print Wi-Fi.scan. We aren't getting anything because okay, Wi-Fi may not be defined only. So what we can do is, before connecting to this, I'll comment this out. Comment out, and I want to do Wi-Fi scan. And I'll run it. Connecting to Wi-Fi, but okay, again a mistake. Wait a second, I didn't print the settings. I need to print this. Print Wi-Fi.scan. Run it. We are not getting anything. That means it is not able to scan anything. Maybe, or the thing is that I actually know what's the SSID and everything of my Wi-Fi, particular Wi-Fi. So I'll just enter it and then we'll see whether it's able to connect it or not. Okay. So I'll remove this command. Again, it's not able to connect obviously because WokWi guest is not my Wi-Fi. My Wi-Fi is, first of all, I need to toggle this. Great. Let me see my network configuration. It's Shaurya. The password is RA123456789 and let's see if this works. Run it. Connecting to Wi-Fi. Okay, so Wi-Fi internal error. There is some error. What I'm going to do is I'm just going to press reset by enabling and disabling the chip. Press this enable button and see, now it's connecting. It's just a problem. It has already connected and okay, to change this, let's start a counter value from, let's say 50, so that we can see a clear difference in the graph over there. I'll interrupt this. I'll run it again. Connecting to Wi-Fi, connected 51. So I should see 51 in the graph. Let's go back to my ThingSpeak window. Where the ThingSpeak? Here's ThingSpeak and see 51. We got 51 in the same channel. So we have successfully communicated our data to the ThingSpeak server. Now, before ending this session, I would like to point out some important things. What we did today was not something very complex. It was fairly simple. And that's because over the years, engineers and developers have improved the entire IoT ecosystem so that it's easier for the end user to implement IoT based automation. My agenda for today's session was to give you all enough insights into IoT and its implementation on embedded systems and get you all excited about wonderful automations. I'm not saying that after attending this you will become great automation engineers, but today you have gained adequate knowledge to bring your great automation ideas to life. Now, let's discuss upon the current automation demands of industries, and let me switch back to PPT. You can see, drone springs, fertilizers or sprinklers. So consider a scenario of agriculture industry where IoT is being used for automating various tasks such as irrigation using sprinkler systems, spraying of fertilizer using drones, etc. If this is happening in a remote area where the internet connection is unstable, you no longer have access to the latest weather forecasts and your pre-programmed automation irrigates the land on a regular basis. Now in this era, global warming has led us to a state where weather changes in a blink of an eye. Like to the left it's sunny, to the right it's raining cats and dogs, which means you have flooded your irrigation field, leading to crop destruction. So your devices need to react immediately to their surroundings, irrespective of internet connectivity, and take necessary action automatically to resolve the problem. meaning your devices always need to be on the edge, and this introduces the new concept of edge computing. So what is edge computing? Edge computing is the deployment of computing and storage resources at the location where data is produced. So let's come back to our example of agriculture and understand how automations can be implemented. When you have internet connectivity, you send your sensor data like temperature, soil moisture and pH levels to the cloud. You learned about web scraping in yesterday's session, so you can collect data from weather.com and all this gets stored and analyzed in cloud servers. From that particular analysis that you have done on the cloud, you take a decision about when and how much water is needed by the crops, and you send commands back to your devices in the field to operate your sprinkler systems for the desired amount of time. All this kind of analysis and decision making is done using machine learning algorithms. But the thing is that everything is happening on the cloud and hence dependent on internet, and this is highly unreliable. So we bring all that computing and storage of data down to the device itself. We deploy all the required sensors and pass all the information collected through our ML models. Here we face a major problem because ML models require intensive computing power, which was not available at the microcontroller level yet. Star of today's session, the Esp32 microcontroller packs in it dedicated hardware accelerators to run the machine learning models, ensuring power efficiency at the same time, because these are all low power devices. But how was this possible? One of the major contributors include Google's Tensorflow program. Those who are familiar with machine learning would already know about it. Tensorflow is open source library for developing machine learning models. Most of the support is in Python. The guys at Tensorflow made the algorithms efficient enough so that the trained model takes less storage. They even went ahead with providing us with simple commands to convert a Python based model to C or C++, so that it can run on a microcontroller in less time, leading to high speed decision making. Problem solved. The next demand of industry is privacy and security. Industries can't afford to get their data leaked, and as they say, data is the next big thing. So we need to secure our entire ecosystem, not only at the software level, but at the hardware level as well. Today, we discuss two major communication protocols for cloud, namely HTTPS, S standing for secured, and MQTT. I told you that SSL WebSockets can be used to secure your MQTT protocol. The cloud itself has to remain secure so that no one can hack into it. For this, we implement blockchain technology to secure our data ledger. This was the software part. On the hardware side, we need to ensure that if someone gains physical access to our devices, they shouldn't be able to break into it and disable the crucial systems, just like in the home automation project that I showed you in the beginning. For that, we have secure boot and flash encryption, which is one of the major features of ESP32. That is why I introduce you guys to this powerful and secure microcontroller. Secure boot is a feature which ensures that only your code can run on that chip. Data loaded from the flash is verified on each reset. And we learned all these things. I hope I have given you enough insights about automation and how all these things can come together to make a great project and eventually a great product. With this, we end our session. Please scan this QR code to fill the attendance form and give your feedback for today's session. And don't worry if the last 2 minutes went above your head. We are always there to help you. You can replay the YouTube video later after the session ends, and I'll be on our Discord server for at least an hour, and you guys can join the voice channel Doubts 1 and Doubts 2 in AutoWare section. We can discuss your doubts. And don't worry, we are going to implement and learn these concepts in detail in our upcoming sessions, so stay tuned. Hop on to our Discord server, subscribe to the YouTube channel, follow us on Insta, and the most important thing, keep this enthusiasm to learn and explore more about robotics and automation. This is Shaurya Chandra, Technical Head of IEEE RAS, signing off.